Hey, hi everyone. Welcome to another video in our innovation frameworks series. So, this is a part of our innovation technology and product management series. So, we have discussed about TRIS and we went through the 40 principles of TRIS and some examples at a higher level. What TRIS stands for? It came from Russia and can be used for product innovation and technological innovation. So the second topic for today is QFD, and we will talk about QFD. This is from Japan and how it came into existence, how who invented it. We'll go through some real life examples from US, UK, and India, and how it can be used. Okay. So QFD stands for Quality Function Deployment. So that's the full form of it, and it's a structured method of transforming the customer needs. The customer needs in this framework are called voice of the customer into engineering characteristics and the design priorities. Transforming the customer needs into engineering characteristics and design priorities. Simply, in simple words, if you have to put this, it helps the team build right product the right way, but translating what customers want into what engineers must design. Okay. The main tool of QFD is called as a house of quality. It's a matrix that maps what the what's, which are the customer requirements, into with the house, which are the technical features that satisfy those requirements. And it then analyzes the relationships, the conflicts, the priorities, and competitive benchmarks as a part of this whole of quality matrix. So, who invented QFD and historical background? Its origin is in Japan, and it's invented by Dr. Yoji Kawo and Shigeru Mizuno in the 60s and late 60s and early 70s. And it's developed at Mitsubishi's Kobe shipyard in 1972 to ensure that customer satisfaction was systematically built into ships before production. It spread to the world. It was adopted by Toyota in the mid 1970s, which improved the quality at Toyota, reduced the design changes, and sped up new product development in Toyota. And it spread to the US in the 80s, especially via Ford, Xerox, and General Motors. Later, it was adopted in UK, Europe, and India across automotive manufacturing, healthcare, and IT industries. So Dr. Akao described QFD as a method to transform user demands into design quality and to deploy the functions forming quality through each stage from product planning to engineering to manufacturing. So this is a traditional QFD, a house of quality, okay, a matrix. So what is the customer requirements and will be there, house will be there, the technical features, correlation roof will be there, trade-offs will be there, customer importance will be there in that matrix, relationship matrix, competitive benchmark and target values will be there. We'll go through those house of quality examples. Okay. So customer requirements are the what's. So key components of QFT. So example of what is, I want the phone to charge fast. I want the car to be safe. Okay. Technical requirements. House are measurable design specs that can satisfy the what's. Example, battery capacity, braking distance. Then relationship matrix. How strongly the how affects each what. Okay. And then importance ratings. The customer requirements, each one how important it is, prioritized based on the customer input. Competitive benchmark to see how we rate or how competitors perform on this same requirements. Correlation roof, this shows positive and negative interactions between the technical features. And last is target values, which shows the final engineering goals. So these are the key components of QFD. How QFD works: step by step, it collects the voice of the customer through surveys, interviews, social media, and field data. Then lists those customer requirements, which are the was in customer's language. Then it translates these into technical requirements, which are the house, into measurable design parameters. Then it builds the house of quality, which maps relationships strong, medium, weak between the what's and the house. And it prioritizes engineering actions, computes importance weights, okay, and it sets target values and benchmark the competitors. Okay, a cascade to next levels is product, component, process, production, and service. Okay, so real life, before we go into real life QFD examples, I want to show you some of the QFD house of quality matrices, how they look like. So this is a house of quality matrix, okay, and you see here, these are the customer requirements, and this is, you know, the design parameters, and there's a priority here, okay. So if you see, there's a priority here, importance and weightage is there, then comparative assessment is there, relationships are strong is medium and weak are shown like this. Okay, correlation is shown with these symbols, and the companies are represented by F, S, and P here. So this is an example of flyco drones. Specifications are the drone should be stylish, lightweight, quiet, should have a super HD camera, stable, long range, self-directing, programmable parts, high quality finish, durable body, long battery life, and remote battery life. Same things are mapped here, like styling, jewelry, weight, size, noise output, horizontal pixels, gyroscope variation, kilometers, W26 chip, W11 chip, infrared sensors, stress test, and minutes. And then you can see like a strong relationship between stylish and this uh, technical parameter is there. This is a strong relationship is mentioned here. Weak relationship between weight and stylish is mentioned here. Like that, the relationships are mentioned. Okay, so quiet and noise output, there is a strong relationship. Lightweight and weight and size have a strong relationship. Okay, self-directing and this W26 chip has a strong relationships. And similarly, there is medium relationships are also portrayed by this, circles, like you see self super HD camera and this minutes has a medium relationship. Weak relationships are also mentioned here. Okay, so like that we plot the customer specifications, which are the what's with the house, how we go design it. Then we do a competitive assessment. Well, then we importance weightage each requirement. How much weightage, it's 4 6, like that. Styling is 4%, weight is 6%, like the total 100%. What is the importance weightage of that particular thing we will weigh. And then we'll do a comparative assessment, like on for example stylish, Samsung has a 5 rating, whereas this Flyco has only 3. Whereas on lightweight Flyco has more. Like that we will come up with this matrix. Okay, we'll go through a few other examples. There are other examples also for QFT. So like this also we can, for example, luggage carry device. So these are the requirements. It doesn't have shoulder adjustable to user height, packs away small space, carry heavy suitcase, not sleep bag, gentle on clothing, small plastic logo, durable, not expensive to buy. Like that it is there. And okay, then the technical parameters: ergonomic shape, shoulder pad surface, thin pad, flexible, like that. You'll map all this. And then relationships, like strong relationship is 9 here. Numbers also you could use instead of symbols. Medium is 3, weak is 1. Like that we can use the policy weightage is mentioned here. Okay, so this is another example. So we went through two examples. Yeah, so let's go through the third example for the QFT. So this is this is a customer requirements, which says for a auto insurance claim services. So it says speed and accuracy are needed, and these are the tertiary requirements, which are ability to report claims 24 hours per day, claims status report in 2 days, final settlement in 10 days, professional adjuster statement, settlement review before final action, arbitration option, and independent. Okay, and okay, so this is strong positive correlation. So these are the technical things again: response time, toll free phone number, 24-hour staffing, on call representatives, and field drafts, certified adjusters, extending geographic coverage, arbitration process. So each one has its own solution: response time, adjusted staff, and settlement process. So preliminary finding, okay, and claims and auditors. And then there is a relationship. A strong positive correlation is inverted triangle. Positive relation is a square, and negative relation is a circle. So like this, this QFD house of quality is built. Okay. So now let's go through some. Yeah. So we went through what is QFD, how QFD house of quality looks like. Okay. With various examples, we have seen some real life examples also. Let's see. So example of from USA is Ford Motor Company. So voice of the customer car here. Okay, so in 1980s Ford faced some high customer dissatisfaction and strong competition from Japanese automakers. And the QFD was used there. They collected detailed customer preferences, and they found that a car needs to be quiet, cabin, safety, and fuel economy. These are the customer preferences, and they translated these into measurable engineering specs like NVH levels, noise, vibration, and harshness, crash energy absorption, aerodynamic drag, etc., and built a house of quality to align design, engineering, and manufacturing teams. Okay, so outcome is the reduced development cycle by 30% and improved customer satisfaction scores. And the Ford Taurus was one of the first cars designed using QFT principles and became a best seller. Yes, so other example is UK example, Rolls-Royce Aerospace jet engine reliability. So problem was airlines demanded engines with higher uptime and lower maintenance costs, and QFT was used here. So customer watts include reliability, service turnaround time, and fuel efficiency. And technical houses, material durability, modular design, predictive maintenance sensors. QFT mapped which technical changes would impact the airline satisfaction. Outcome is prioritized development of modular engines. Okay, quick swap modules for maintenance is one outcome. Launched powered by the our model, now industry standard, and demonstrate QFT's use in B2B complex engineering products. Third one, Indian example is Tata Motors Nano Car project. So problem is deliver the world's first most affordable car without compromising basic safety or quality. QFT use customer watts, affordability, safety, fuel efficiency, and easy serviceability. Technical house are low cost material, simple assembly, two-cylinder engine, efficient engine, lightweight body, minimal electronics. Relationship matrix show lightweight materials affected multiple customer needs positively. Okay. Outcome is Tata Nano became an engineering showcase of cost innovation, and it used QFT to manage trade-offs between cost, safety, and comfort. It demonstrated how QFT enables frugal innovation for developing markets. Example two is healthcare, Mayo Clinic. So the problem here is improving the patient satisfaction and reducing waiting time here. So the QFD used is what's less waiting time, personalized care, and friendly staff. That's the requirements, customer requirements. How to do it? Patient scheduling systems. They have introduced EMR, electronic medical records, usability, staff-patient ratio. Those were the house. Relationship matrix identified digital scheduling plus communication training as most impactful. And this reduced the average waiting time by 40% and improved patient satisfaction metrics. Measurable service innovation through QFT. Okay. Other example is Dyson product development. It identify features for next generation vacuum cleaners. So QFT was used here, collected the voice of customer data from 30 plus markets. Watts are easy to clean and lightweight, quieter, and better suction. So that those are the watts. The house is cyclonic airflow design, new brushless motors, noise dampers, and composite materials, and prioritized suction versus weight trade off through QFD matrix. You know. Outcome is released Dyson V series cordless models V16 to V15, which reduce the noise and improved suction and direct reflection of QFD prioritization. Example two from India is Apollo hospitals. So patient experience. So improve the patient experience and efficiency in outpatient department. QFD uses WATS, which is quick registration, shorter waiting time, and empathetic staff. How is digital? They achieved this quick registration, shorter waiting time, and empathetic staff through digital registration kiosk, queue management system, and staff training modules. So they used QFDs to see which technical interventions affected patient satisfaction most. Deployment of smart OPD outpatient system in major Apollo hospitals, and this enhanced net promoter scores and process efficiency. So where QFD is used today in automotive industry, it aligns customer priorities with engineering targets, range, safety, comfort. Aerospace industry or domain converts airline needs into maintenance and design targets. Healthcare domain maps patient needs to process and service design. IT and software translates user stories into technical epics and feature priorities. Education domain aligns student and employer expectations into curriculum design. Public sector links citizen requirements to service design. How QFT connects with other frameworks? TRIS, it connects with TRIS and it helps solve, TRIS helps solve technical contradictions that appear in QFTs. Okay, and with Six Sigma, QFT is used in the define and measure phases to identify critical to quality factors. With design thinking, QFT formalizes the define and ideate stages into measurable engineering plans. And with Agile, it acts as a strategic front end to guide product backlog priorities. Okay. Another example is given is mini QFT table, okay, which is a smartphone camera. So again, the watts here are high quality, low light photos, long battery life, sleek design, and fast focus. Importance is 9878 is given here. Technical parameters are large sensor aperture and efficient image processor, lens size optimization, and face detection pixels. Relationship strong, medium, weak, strong, and priority is also given 81 and so on. So result is prioritize larger aperture and face detection technology first, clear technical focus for design engineers. Okay, that's an example how it can be used to develop a high quality low light photos with long battery life and sleek design and fast autofocus. So benefits of QFD in innovation is keeps innovation customer driven and not engineers driven. Reduces rework and design changes. Aligns multidisciplinary teams, marketing, design, and manufacturing. It quantifies the customer satisfaction improvements. It helps benchmark against competitors, and it integrates seamlessly with the TRIS, Lean, Six Sigma, and Agile. So, at a glance, QFT inventors are Dr. Yoji Akao and Shigeru Mizuna in Japan. Core idea is to translate voice of the customer into voice of engineer. Key tool is House of Quality Matrix, and it's used by Toyota, Ford, Rolls-Royce, Tata, Dyson, and Apollo hospitals. Outcome is higher quality, low cost, faster development, and happier customers. So that's a QFT for you guys. Thanks, everyone. We went through another framework in innovation. We went through TRIS first and then QFT next. Okay. Thank you, everyone. Have a nice day. Bye.